5.1 Systems of Linear Equations. Now, in order to solve a system of linear equation, you can graph the two lines and find the point of intersection, or you can do substitution or elimination. So in 5.1, in this section, I'm going to show you substitution and elimination. So the first couple problems, we're going to work using substitution. First example, 4x plus 3y equals negative 13, and then negative x plus y equals 5. Now you're given two lines, okay? These are two separate lines. And what I'm looking for is the ordered pair where these two lines are going to meet, where they intersect, okay? So your answer would be an x and a y coordinate, okay? So when I have two equations, I ask myself, okay, which equation looks smaller? What I mean by smaller, the coefficients in front of x and y are 1. Meaning when I solve for x or if I solve for y, I won't have any fractions. So the second equation is considered the smaller equation. There's a negative 1 in front of my x, and there's a positive 1 in front of my y. So I can easily solve this equation for x or y. And so in this case, I'm going to solve for y, and it doesn't matter. And the reason I'm going to solve for y is because it's positive already. So that means I move my negative x over, make it a positive x, plus 5. Now what I'm getting ready to do is I'm going to sub in the place that says y equals. So in the first equation, where y is, I'm plugging in x plus 5. That's what substitution means. You can't solve an equation with two variables, with x and y. So I have to plug in for one of the variables. So I'm going to go back to the first equation. I have 4x plus 3, and I'm going to put it in parentheses so you can see my plug-in where the y was. I'm putting x plus 5 equals negative 13. And I'm going to solve this equation for x. So I have 4x plus 3x plus 15 equals negative 13. You do know you distribute. Combine like terms. 4x plus 3x is 7x. Plus 15 equals a negative 13. I'm going to subtract 15. I get 7x equals a negative 28. Divide by 7. X equals negative 4. So my x coordinate is negative 4. Now, I need to know my y coordinate. So I'm going to take my negative 4x, and sub it in to the second one where x is. So you have y equals negative 4 plus 5. So y equals 1. So you have both your x and y coordinate. So these two lines, they will cross, they will meet at negative 4, comma 1. That's the ordered pair. That's what I'm looking for, is my point of intersection. Second example, 3x plus 4y equals 4. And then x minus y equals 13. And again, when I look at the two equations, the second equation is the smaller equation because the coefficients in front of x and y are 1s. So I'm going to solve the second equation. It does not matter if you solve for x or if you solve for y. Just to make that point, I solved for y on the last one. I'll solve for x. He's already positive. So I'm going to move my y over, make him a positive y, and bring down my 13. So here I go with my substitution. In the place of x in the first equation, because it says x equals, I'm going to plug in y plus 13. So I have 3, and I put it in parentheses, y plus 13, so you can see my plug-in, plus 4y equals 4. So we're going to do distributive property. 3y plus 39 plus 4y equals 4. Combine like terms. You have 7y plus 39 equals negative 4. Get y by itself. We're going to subtract 39. So 7y, and I had a mistake there. That's a positive 4, my bad. 7y equals 4 minus 39 is a negative 35. Divide by 7. And y equals negative 5. So that is our y coordinate. We're going to take it and plug it in for y in the second to find x. So it says x equals, you're going to plug in negative 5 plus 13. So our x is positive 8. So our ordered pair, keep in mind your x number comes first, then the y number, would be 8 comma negative 5. That would be our point of intersection. That's where these two lines would meet. Example 3. X minus 5y equals 8. And then x equals 6y. Now, this one's pretty simple. The second equation is already solved for x. So this is just a straight plug in, sub in. I'm going to take 6y and I'm going to plug it in for x in the first equation. So we have 6y minus 5y equals 8. So y is just 8. And then you're going to take 8 and plug it in for y in the second. So x is merely 6 times 8. So your x is 48. So our ordered pair would be 48 comma 8. That's our point of intersection. Example 4. 8x minus 10y equals negative 22. And 3x plus y equals 6. So when I look at my two equations, the second one would still be considered the smaller equation because I do have one variable that only has a 1 as a coefficient, and that's y. So I wouldn't have any fractions. I'm going to solve for y. Y equals subtract my 3x, so that'd be negative 3x plus 6. So, in the place of y in the first equation, we're going to plug in negative 3x plus 6. So we have 8x minus 10. In parentheses, I'm putting negative 3x plus 6 equals negative 22. We have 8x. We're going to do distributive property. Watch your signs. Negative 10 times a negative 3 is a positive 30x. And negative 10 times 6 will give us negative 60 equals negative 22. Combine like terms. 8x plus 30x is 38x. Minus 60 equals negative 22. I'm going to add 60 to negative 22. And we get 38x equals 38. So when we divide by 38, x is 1. So we're going to take x equals 1. And in the place of x, we're going to plug in 1. So y equals negative 3 times 1 plus 6. That's negative 3 plus 6. Y equals positive 3. So our point of intersection would be 1, 3. Example 5. 3y equals 5x plus 6. And we have x plus y equals 2. So here, the second one, both x and y have coefficients of 1. So it doesn't matter which one you solve for. If you're in the habit of solving for y, solve for y. If you want to solve for x, solve for x. So I'm going to solve for y. And that means I'll have negative x plus 2. So in the first equation, where y is, we're going to plug in negative x plus 2. So I'm going to put that in parentheses 3 times negative x plus 2 equals 5x plus 6. We're going to do distributive property. Negative 3x plus 6 equals 5x plus 6. So we're going to put variables on one side, whole numbers on the other. So negative 3x minus 5x equals 6 minus 6. Combine like terms. That's a negative 8x equals 0. Now, if you divide by negative 8, look where your 0 is located. It's on the top of a fraction. So I don't want you to think this is a special equation or it's a no solution because your 0 is not on the bottom. The 0 is on the top. So your answer is just 0. Your x is 0. And you can have an x coordinate of 0. So that's our x. We're going to take 0 and plug it in to the second equation. And if you plug in a 0 where x is, you get y to be just 2. So our ordered pair would be 0, 2. It's our point of intersection. So these first 5 problems, we did substitution. So the next 5 problems, I'm going to give you 5 examples. We're going to use elimination. And elimination is just what it says. You're eliminating getting rid of one of your variables. So this would be example 6. We have 3x minus y equals negative 4. And we have x plus 3y equals 12. Now, this is not a rule. This is just a habit. When I do elimination, I like to put my equations on top of one another so I can manipulate or change my equations easily. Sometimes it's easier to see when your x's are stacked on top of each other and your y's are stacked on top of each other. Now, what I mean by eliminating is that if I wanted to get rid of the x's, meaning I want them to be gone, I would need to multiply one of these equations by a number that would make it cancel out. So let's look what we have. On the top equation, you have a 3x. So look at the bottom equation, you just have x. So if I wanted to eliminate the x's, I would need to multiply the bottom by negative 3. Because if I do that, that would make my x term be negative 3x. My top term is a positive 3x. Negative 3x and positive 3x would cancel as 0. Another way to eliminate, if I want to get rid of my y's. You have a negative 1 on the top y term, and you have a positive 3y on the bottom term. So if I wanted to get rid of the y's, I would need to multiply the top one by 3, because that would make me have a negative 3 and a positive 3y, which would cancel out. So it doesn't matter. I normally cancel the variable that's already opposite signs. That way I don't have to multiply by a negative. If I cancel the variable that has opposite signs, I had to multiply by a positive. So it does not matter, but I'm going to get rid of my y's because I like to multiply by positive numbers if at all possible. So I'm going to multiply the top equation by positive 3. Now what that will do is only change the top equation. Your x becomes a 9x minus 3y equals negative 12. Bottom equation will stay the same. And then I put that plus sign there. You're going to combine like terms. So my x term, 9x plus 1x is 10x. My y's, the reason why we're eliminating, they're gone. Negative 3y and positive 3y is 0. Equals negative 12 plus 12 is 0. So when I divide by 10, watch where your 0 is. It's on the top. So that means my x coordinate is just 0. This did not cancel out to no solution because my x did not cancel out. So my x coordinate we found to be 0. Now in order to complete the problem, to find the y, I'm going to have to do substitution. So you're going to go back to the original two equations. It does not matter if you utilize the top one or the bottom one, but you're going to plug 0 back in. So I'm going to use the bottom one. I'm going to sub 0 in for my x. So that just leaves me with 3y equals 12. If I divide by 3, my y is 4. So our ordered pair, our point of intersection, is 0, 4. Next elimination example. 4x plus y equals negative 23. And then x minus 2y equals negative 17. So again, you want to eliminate one of your variables, either x or y. I'm going to eliminate the y's because they're already opposite signs. So if I do that, all I need to do is multiply the top one by positive 2 because I already have negative 2 on the bottom. So when I do that, my top equation becomes 8x plus 2y equals a negative 46. My bottom equation will stay the same. And then we're going to combine like terms. So 8x plus x will give us 9x. My y's cancel out. Equals negative 46 minus 17 is a negative 63. Divide by 9. X equals negative 7. And again, we're going to sub that negative 7 in. 4x in either the top one or the bottom one. It does not matter. So if I use the bottom one, x minus 2y equals negative 17, and I plug in negative 7 for x, I'm going to get y by itself by adding 7. Negative 2y equals a negative 10. Divide by negative 2, and y equals 5. So our ordered pair is negative 7, 5. That's our point of intersection. Example 8, 2x minus 3y equals negative 7, and 5x plus 4y equals 17. Now, this particular one, I don't have a single x or y, meaning single, my coefficient was 1. If you notice, on my x's, I have 2 and 5, and on my y's, I have negative 3 and a positive 4. So I'm going to have to multiply both the top and the bottom by something that will give me a common number. If you're trying to get rid of your x's, 2 and 5 both go into or divide into 10. So you're trying to make your x's equal 10 and negative 10. Therefore, it will be 0, which will cancel. My y's, I have a negative 3 and a positive 4. Their common factor, not factor, but multiple would be 12. So I would need a negative 12 and a positive 12 to make it cancel. So because, again, my y's are opposite signs, I'm just going to lean to get rid of my y's. You could get rid of the x's. If I were to get rid of my y's, I would need to multiply the top. If I'm trying to make that y be 12, well, in this case, negative 12, I'm going to multiply the top by 4. For the bottom, you already have a 4, so I'm going to need to multiply by 3. Because your whole aim is to get negative 12 and positive 12y. So, our top one changes to 8x minus 12y equals a negative 28. Our bottom one will change to positive 15x plus 12y equals 51. Combine like terms. 8x plus 15x will give us 23x. Negative 12y and a positive 12y cancel out. They're eliminated. Equals negative 28 plus 51 is 23. Divide by 23, x is 1. And then next, we're just going to take our x and sub it in. So I was using the bottom one. I'll use the top one this time. Because I don't want you to think you have to use the bottom. You can use either equation. So in the place of x, I'm going to plug in 1. So that gives us 2 minus 3y equals negative 7. Solve for y. That'll be negative 7 minus 2, which will give us a negative 9. Divide by negative 3, and your y will be positive 3. So our point of intersection will be 1, 3. Example 9. 9x minus 5y equals 1. And negative 18x plus 10y equals 1. So here my x's and y's are both opposite signs. And it looks like if I multiply the top one by, let's say, 2, because if I'm trying to get rid of the x's to get 18, I would need 9 times 2. And if I'm trying to get rid of the y's to get 10, and I have a 5 on top, I'm also need a 2. So if you notice, if you multiply by 2 on our top, that gives us 18x minus 10y equals 2. Leaving our bottom, you should notice that not only will you get rid of your y's, but you get rid of your x's. They both eliminate out. You get 0 for both variables. So this is very unique. This is very important. The x is gone and the y is gone. So this entire side is 0. Both variables have canceled completely out. Okay? And it's equal to a number of 3. Now this should be similar to us working a no solution problem, because this time, not like on the previous problems, we've had our number to 0 out, not a variable. Here you got both variables that are 0. They're eliminated, they're gone. So that's a false statement, because 0 can't equal anybody but 0. So 0 does not equal 3. So this could be the same as you saying no solution, which means they don't intersect. They don't have a point of intersection. So that means in systems language, you would tell me that this is an inconsistent system. That's the terminology that we use. It's inconsistent system. It's the same as no solution. 0 with a line through it. Our variables are both gone. So that's a special problem. They don't intersect. Last problem, example 10. 4x minus y equals 9, and negative 8x plus 2y equals negative 18. So, if I want to eliminate, kind of have the same situation as the previous problem. 4 and 8 and 1 to 2. If you multiply the top one by 2, you will get an 8 on your x and a negative 2 on your y, which will eliminate both the x and the y. But finish the problem out. We got 8x minus 2y equals 18 on top, and our bottom will stay the same. So if you notice, you have eliminated the x, that zeroes out. You've eliminated the y, that zeroes out. This entire side is 0, no variables. But also, your number zeroed out. So this is very similar to when we worked equations, identity, because this is a true statement. 0 does equal 0. Everything zeroes out. You don't have an x, you don't have a y, and you don't have a number, a constant number. So when everything zeroes out, the terminology that we use is called infinitely many solutions. Infinitely many solutions. In other words, every point on that line is a solution. It's a point of intersection because it's the same line. It's kind of like saying these two lines are on top of each other. So every point would be an intersection point. So that's why we would say infinitely many solutions. And this will conclude 5.1.